Good morning, everybody. We're back at work. Quick little shift, just day shift today. Whew, hope we don't get any rain out here. It's all right. Got to get this one ready to go to Haneda. Welcome back, everybody. Hope everybody's doing well. Welcome to another Stig shift. This week's schedule was a little bit wonky because I had just came back from Chicago from the competition. So the days of work were a little staggered. They weren't back to back. But not to worry, we're going to have lots of fun, learn a lot of new things, and see a lot of cool stuff. As I mentioned earlier, we are performing an Eops check on the 787 because it is going out to Haneda. Now, I've talked about in the past and previous videos of what we do as maintenance for an Eops check. You know, engines turn or people swim. I'm just joking, guys. Extended twin engine operations. That's what it really stands for. Or just in short, extended operations. It's for twin engine aircraft that are rated to go prolonged amount of distance. So when that happens, we perform a lot more scrutinized checks. Actually, an interesting fact I learned the other day, the Airbus A350 broke the record on Eops certification. It flew for 370 minutes nonstop. What this means is actually quite incredible. The aircraft can fly more than 6 hours on one engine and land at an alternate airport up to 370 minutes away if one of the engines failed. That's quite impressive if you ask me. But regardless, we keep on going with the check. One of the things we do have to perform is an inspection of the cargo pits. So here we go. This is the aft cargo pit of the 787. Open sesame! So one thing about the 787 door is a quite interesting change of design from the 777 to the 787. It is hydraulically actuated, electrically controlled, but hydraulically actuated. It has its own independent reservoir, completely separate from the aircraft hydraulic systems. The 777, on the other hand, is fully electric. This area is called the ball mat, or the ball mat rollers. Basically allows the pallets to move smoothly across the surface. Here's something cool for you. So this is how you would control all those PDUs over there on the floor. Well, watch this. Cool little trick. Turn the power on and it gives power to the PDUs. But it's funny how the camera works. It can actually pick up the optical sensor on here. Watch this. Can you see it? So a quick little description, this is the PDU, the power drive unit. This is what actually moves the pallet from the bottom. Two types of these, there's a self-lifting and there's spring lift. Spring lifted ones are always up. The self-lifting ones are installed on the ball mat laterally to move the containers in and out. They all contain an optical sensor. There's a pallet on top, it knows it. It knows that there's a pallet on top, the gear-driven cam inside that little unit will raise. Right there. There it is. That means the PDU is getting power. Pretty cool, huh? If I turn it off, you won't see it. Watch. See? It's gone. Cool little trick, huh? The reason I said it's a cool little trick because it's a way of troubleshooting. Let's say one of those things don't work and you were trying to figure out which one is not working. That's a quick way to do it. So yeah, if you're a mechanic and working on these, there you go. And here's the PDU in action. From time to time, there are very heavy pallets. And remember, these things are electrically driven. So if it feels an overload and the system stops working or that PDU stops working, most likely either it failed or popped a breaker. Here she is, you know, plastic princess. Let's go. Make sure everything is A-okay, no faults, no issues. We are almost done here. Just a quick walk through the cabin, make sure all is good. Everything's looking good. This one's ready to go here in a little bit. A common question I always get asked is why are the window shades usually closed or dimmed when the aircraft is at the gate? Well, the simple answer is to keep the cabin nice and cool, especially if it's a very hot day outside. It's for you, it's for the passenger, for cabin comfort. But for takeoff and landing, they want them open just in case of an emergency evacuation. A quick look at the APU inlet door right there for the 787. Okay, something really interesting. So the APU can function when it's flying. And yes, even with the door wide open like that. Let me give you some interesting facts about this one. So I've talked about this before. This particular APU is a bleedless APU, so no bleed air being tapped off. It's purely a source of electrical power. It has 2 starter generators. At sea level, it can produce maximum supply of 450 kVA, but at about 43,000 feet, the APU can only supply 100 kVA. And if you were wondering, yes, you can start this APU at 43,000 feet. Trust me, it's not going to rip off the intake door. It looks like it will, but it won't. It's built very strong. Oh no, we got a hole in our door. No, I'm just joking. That is actually called a vent flap. There's 3 reasons for the vent flap. It prevents the aircraft from pressurizing if the door is not fully locked. It prevents you from operating that door if the pressure is too high or unsafe for operation. And number 3, it releases the remaining pressure to prevent any kind of damage when you unlatch the door. It's a very simple mechanism that is tied into the actual handle that opens and closes the door, as you can see right here. You can see this on a variety of aircraft, one of which is the 787. 777s also have this. You'll see this on cargo doors. Overall, another safety feature. Let's switch gears here for a second and let's talk about an incident Southwest had. I'm sure everybody's already seen this a million times before and I've been asked about it. This is that incident where Southwest 737, the fan cowlings decided to say I quit without putting in a 2 weeks notice. I'm going to explain what happened, or what I think happened, and I'm also going to show you some safety features that are implemented in other aircraft to prevent this from happening. The engine in question is the CFM 56-7B, equipped on the 737-800. So let's take a look at the CFM 56-7B up close, especially the part that failed, the fan cowlings. Fan cowlings are made out of mostly composite material with some reinforcement aluminum. They are a 2-piece cowling. They are split like a clamshell and they're held by these latches as you can see at the bottom. When we perform maintenance, we'll unlatch this, open the cowling, and just work on the innards of the engine. Now what I want you to focus on really closely is the latch itself. That's the culprit. There's 2 possibilities that could have occurred within that incident. Possibility number 1, improperly latched fan cowlings. By the way, this isn't the first time it's happened. It's happened on other engines as well, such as V2500s, other CFMs. To be very frank with you, yes, that is a maintenance issue because if they opened that engine and closed it and did not properly latch it, that's the result you're going to get. The fan cowling is going to go bye-bye. Reason number 2 would be the failure of latch or latches, simply due to wear and tear and deterioration. Just to make you understand, I am not an investigator, I'm not NTSB. This is just simply my perspective and what I understand on how these latches work because I deal with this engine. I work on these engines. So the only 2 possibilities in my mind would be those 2 possibilities, either improperly latched or a latch failure itself. Take what I say with a big grain of salt and let the professionals and investigators figure that one out. So I'm sure everybody's seen the Southwest 737 losing its fan cowling, and the engine that's equipped on that Southwest 737 is the CFM 56-7B. Well, this is a sister engine equipped on the Airbus right here, 319. This is the CFM 56-5B. Now, Airbus did a little thing over here to prevent that from happening. Now you need a key to unlock the fan cowling. Yep, you heard me right. You need a key to unlock that latch now. Airbus and CFM got together and say, how can we prevent this? And we need a very simple rudimentary design. They said, let's make a key that needs to go inside to unlock that latch. And not only that, it will stay with the latch with a big lanyard. I'll show you that in a second here. What this will do is basically prevent someone that is working on the engine. It prevents them from forgetting to latch that thing. This is a V2500 and also implemented on this one. You need a key. And as the sign says, the key is within the flight deck or the cockpit. Also, the latches, or most of them, are painted bright orange because when we are doing our walkarounds, we duck down, we look, and if we see something bright and orange, that means something's out of place or not latched properly, but that's part of the walk around. Let me show you the key itself. Here we go. As you can see, a very simple rudimentary design. A little key that will go into that latch and stay in that latch until it is ready to close. And once you close it, you can remove the key. Otherwise, it stays in there. It gets locked in. So now let's take a look at the Leap version, or the CFM Leap 1A version of this, the protection on this. Now you have a multitude of safety features. Number one, you'll get a flag that sticks out of the side of the fan cowl. Not only that, you'll also get an indication within the flight deck. Actually, this is public information. Airbus actually gives it to you free online. Just visit their safety forum, safetyfirst.airbus.com. Go check it out, read for yourself. There's plenty of amazing information. Check it out. This is simply a quick little scroll through of all the stuff that I found. One thing about aviation, especially commercial aviation, a lot of the safety features are not secret things. You can research it yourself. And by the way, there, right there, that little engine 1 or 2 fan cowl not closed is the indication that you will get on your ECAM. This is what the flag would look like if the engine cowlings are unlatched. It is connected to the number 1 latch, and as soon as the latch is opened, this little flag pops out on the side. Simply put, evolution of aircraft is always growing and safety features are improving all the time. So hopefully this better helps you understand why that incident occurred. Hopefully, Boeing and CFM can work together and create another safety feature for that other engine to prevent something like that from happening. Anyway, moving on. Let's go. Well, it looks like I spoke too soon. Now it's pouring. Whew. Anyway, next office. Let's go. 777. That is hot. Look at that. It was one of those days. It just started pouring. Thank goodness for rain gear. It's all right, though. A little water didn't hurt anybody. That's pretty cool. When the doors open on 777, look, you can actually see the slide. There it is. All right, finish up our walk around and go upstairs, see what we got. I was walking through the cabin and I noticed something, the little blue light right here. And you're gonna see this if you ever go flying. Most aircraft have this. So this little blue light, what it designates that the power port is being used. I probably talked about this before, but I talk a lot anyway. But here's an example. Look, you see this? Somebody had plugged their phone in and they're using the power port. That means the little blue light will come on, meaning that it is being used. All done with the cabin. Go through the parameters. She's a good bird. No problems, no issues. Ready to fly. I always find this funny. Multi-million-dollar airplane, and this is your foot adjustment. Hey, if it works, it works. Pretty cool, huh? And not to forget the fidget spinner. No-go item. Works. Let's go. Wait. Before we go, I have had this question before and somebody asked me, what is that little white X or cross right above the pedal adjustment? Well, that is an eye alignment indicator. I'm going to show this to you later on in the video on a 787 because the 787 has exactly the same thing. And this is more for alignment for a visual cue for the heads-up display when the heads-up display is lowered. But I want you to keep this in mind and remember, This is for eye alignment, to make sure your seat is in proper alignment for flight. So somebody else also asked about the red switches on the pedestal on the 777. The switches I'm talking about are these guarded switches. This is a very important fail-safe feature for Boeing aircraft. Have any of you ever heard of a term called runaway stab? Well, that term has a very specific meaning behind it. Runaway stab stands short for runaway stabilizer. To be more specific, horizontal stabilizer. The horizontal stabilizer is responsible for the pitch control of the aircraft, nose up and nose down. If there was a malfunction, a hydraulic malfunction where the stabilizer is uncontrollably moving up or down, in the cases of the 737 MAX incidents with the MCAS issue, the pilots have the capability of cutting out that function and locking it out. It reverts to a very rudimentary system, either if the aircraft is a fly-by-wire aircraft, such as a 777 that you see right here, or a 737. They can revert back into electrical controls, or they can do mechanical controls, which you have in a 737, which I've shown you, the pitch trim wheel where you can maneuver manually. Now, I know this is a very sensitive issue, especially in regards to the 737 MAX issues and the MCAS and those two incidents. I want you to understand Boeing is very much responsible for that, but there's also responsibility in the pilots that were flying those. If they realized that there was a runaway stab, they should have disengaged that system. One of those pilots did on one of those incidents, but then they re-engaged it. My point being here is that the aircraft has redundancies, it has safety features, and you also have to have proficient pilots who know what they're doing. You cannot just rely on the aircraft itself. The aircraft is just a machine. You need people that are proficient in operating that machine. They need to know what they're doing, especially when something goes wrong. It could have been prevented. That's all I know. That's my standpoint on it, and that's all I'll say about it. Well, that's it for the day. Yeah, I told you guys, super easy day. And it turned out to be nice too. I'll see you guys on the next one. Later. Good morning, everybody. Welcome back to the line. Welcome to another wonderful weekend. Come on, go clock in. Time for some fun. On to the next day, or I should say a couple of days after, but I got assigned into the international terminal, so here we go. We got the wide bodies and we got a bunch of international birds that are coming through. Now, this is a very special moment for me because that 787 is carrying somebody that I love and care about very much. Someone very special to me. And this is why we do what we do. We fix our aircraft because we put our friends and family on our aircraft. You see, that is my airplane. I'm responsible for it. And I take personal responsibility for anybody that's on board on it. This is the level of confidence I have within my job and my field, where I know that I will put somebody that I love dearly onto that airplane and it will fly out safe. That is the dedication. That is the commitment of this job. Not only that special person that's in our airplane, everybody is special on that airplane because every single person, every soul on board might as well be my family, my brother, my sister, my children. Take pride in your work because your work will reflect on who you are. First office, let's go. A quick little walk around, make sure everything's a-okay, and don't worry, that is not aircraft fluid on the floor, that's just thawed out ice. Brakes and tires looking nice and healthy. Don't worry, that's just dirt. Whatever it picks up off the runway or whatever. See? This is the flight deck of the 787, and this is the heads-up display. There was a little nuisance fault that was kicking up on the ICAS, and it actually didn't relate because it wasn't a latch fault. It just needed me to drop down the heads-up display and recycle it. Remember, this thing is a flying computer. Sometimes things need to be reset. But it gave me an opportunity to play around with the system. So what you're seeing me doing here is manipulate the indicated airspeed, which is, you can see the numbers changing on the top left corner. Everything on the primary flight display is reflected onto the heads-up display. So, 787, let's see. Ever wonder how big the potable water tank is? There you go. So the earlier panel you saw, that's the flight attendant's panel. That's inside the aircraft. This is down below at the belly. This is where you actually service the water. Now, I may have spoken on this before, but there's a very cool feature that the 787 has. And that feature is called the ultraviolet water treatment module. Module itself is located in the forward cargo pit in the back wall. During servicing of the water goes through the UV light, and this basically cleans the water. Let me correct my statement there. An extra level of cleaning the water. The water is already clean when it's being serviced. This is also on top of us sterilizing the tanks on an interval basis. So when people ask me, is the water safe to drink on an aircraft? Yes, absolutely safe to drink. I drink it all the time. I drink tea, I drink coffee, a lot more coffee than tea. I've been drinking it for the past 25 years, never been sick. Next office. Let's make it clickety clank. This is the CFM 56-5B equipped on an Airbus, and here's a good look at the thrust reverser blocker doors. Slightly different design because these blocker doors actually pop out of the thrust reverser cowling. Here's what it looks like. This is an old video I took back in the days. We were doing a functional check. Check this out. Pretty noisy, right? All the hydraulics going, the PTU going. Okay, up next, you see that circular panel right there? That's where the fire extinguishing bottles live. Here's what the bottles look like. There's 2 bottles in that pylon, and it's for the engine fire. I know this one says cargo fire bottle, but the engine fire bottles looks identical. Here's a quick little graphic so you can get the idea of the orientation of the bottles inside the pylon. Bottles are filled with Halon 1301, and it's basically there to extinguish any kind of flame if there was one within the engine. Those little pipes that you're seeing, those are pylon drains. In case there was any kind of fluid or leakage inside the pylon, it would come out through there and go overboard. Change your light bulb. Easy. This was an inbound write-up. The flight crew said the work light, or one of the work lights, is not working. Super easy thing to do. Just pull the circuit breaker, make sure there's no power going to it, and just take off the faceplate. I've had a few comments on some videos, and people were concerned and asking, where's your documentation? Where's your maintenance manual? Guys, we're in the digital world. All my maintenance manuals, all my documentation is digital. It's on my iPad. That thing is stapled to my hip. The days of paper manuals are slowly phasing away. Don't get me wrong, we can still print out a paper manual, but it's just, you're wasting paper at this point. Things have gotten so much better nowadays. Technology has advanced. It's so much easier to use. And trust me, I'm coming from an era where I used to use microfiche.
The old mechanics and people who understand this, they will know what that is. It's like going to your local library and scrolling through the old newspaper articles. Yeah, those. I forgot to mention, not only are the manuals digital now, so are the logbooks. There's no more paper logbooks, especially on certain fleets. They're slowly phasing away. And when I'm done with this job, I simply walk out of the aircraft. Obviously, I'll let the pilot know and just sign off the logbook digitally, and the airplane's good to go. After that, it was back-to-back wide bodies. A 787 rolled in, and then right after that, a 777 rolled in, so we were pretty busy that day. For most of you wondering how am I able to work on such a wide variety of fleets, well, I'm type certified on them. That's how we are able to do that. There's very specific training courses and GenFEMs, general familiarization courses that we go through for every specific fleet type. So that's why you get to see me working on 777s, 787s, the Airbus 320 family, and the 737 family. By the way, all the training has to be reoccurrent. So when it comes down to the expiration of it or reoccurrent training needed, I have to go and get basically refreshed on certain systems. Also have to keep up to date in case of any kind of modification or changes within the aircraft. We also have to keep up to date with service bulletin and engineering orders. It's a daunting task to keep up with the technology because the technology is moving very quickly. Unlike a pilot, I mean, pilots can be multi-rated, but they can only fly one airplane at a time. For maintenance, it's a lot more complicated because we work on all different types of aircraft. All right, I'm yapping too much. Enjoy the engine sounds. This beauty just came in from Heathrow, I believe. So she needs a little bit of oil. It's gonna stay here for a little bit, then I'm gonna go to Miami later tonight, but gotta top it off just a bit. There you go, easy. And we'll go upstairs and check the gauge. Well, the ICAS. There you go, nice and clean. As usual. Same old, same old. Here we go. Beautiful. That's exactly what I want to see. No faults, no issues. Engine oils are good. Perfect. No status. Yeah, like I said, this thing's staying here for a little bit.
It's okay, it's going out back later tonight. All right, on a little break. And as always, cargo never disappoints. Look at this. This is beautiful. What a lovely Porsche. There's a couple of them actually here. There's a nice little Carrera too. I'm not quite sure what model this one is, but looks in pristine condition. Look at that. That is really nice. I like the classics. What can I say? Look at that. Lovely color. Nice Carrera 2 right here. Looks pretty stock to me, but that's an interesting interior. I don't think I've ever seen a purple interior. Very cool. A little beat up though. These might be just used. Well, obviously they're used. Very nice. But they got some more stuff over there. Let's go look. Here's a lovely Targa. This is nice, actually. Oh, it's a Singer. Yeah, this is an expensive one, from what I understand. Look at that grill, custom. Hey, you notice something? The steering wheel. It's on the opposite side. The steering wheel's on the other end. How cool is that? That is awesome. How about that? SL65 AMG. That is nice. That's a pretty looking car. V12. And last but not least, I think this is this is a Cadillac. This is a Cadillac. There should be, I think. I don't know what model it is, but it sure is beautiful. Wow. That in pristine condition. Let's see, you guys probably know some of this better than I would. Look at that. This is gorgeous. A little modified with the seats, obviously, and a roll cage. Yeah, I think this might be a race car. Wow. Got the original gauges though. Interesting. What a beautiful ride. There you go. Nice screenshot for you. Told you, cargo never disappoints. Oh man.
Okay, break time is over. Time to go back to work. Our next airplane is about to roll in.
Back to the 777. This one's an Eops check. It's going international to Heathrow. Brakes and tires look healthy. Oh my goodness. Aw. Hi. How about that? That's cool. Alright, here you go. Get back off. The ride's over. Wherever you came from. That little bug was lucky. Most of them don't make it out. Most of them end up like that. Splat. But lucky for that one, it made it.
Aircraft encounter lots of wildlife. Most of it would be insects, and like I said, most of them just go splat, no damage to the aircraft, but it does make a little bit of a mess. And then once in a while, you'll get those instances where you get the massive bugs, and then you're sitting there scratching your head and trying to figure out, is it a bug or a bird? Yeah, that's a fun one. This is a repair, basically a little patch right there that I did on the intake cowling. But I want to go back to basics and I want to talk about fasteners. In order to do that, we have to dive into the dreaded AC 4313. The AC 4313 is an advisory circular. It is a document that's put out by the Department of Transportation and the FAA. It contains methods, techniques, and practices applicable to the administrator. Basically, it tells you how to repair aircraft. To be more specific, general practices. Find a lot of information on this document. It's free online. You guys can check it out. It's even on the FAA website. This is just one chapter out of there. This is just for the sheet metal and repairs. But the whole document is like over 600 pages long. So going back to the actual repair that we're showing, the thing that stood out to me the most is the edge distance. And that's what I really want to talk about. You can see right here, there's two different types of rivets. The ones on the outside are the solid shank rivets. The ones on the inside are blind rivets. Solid shank rivets need to be bucked. So if you have the air hammer on one side, you have to have a bucking bar from behind. When you have no access to buck a rivet, that's when you can use a blind rivet. There's a very specific tool you can attach and just pull the rivet and the shank gets squeezed from behind. I'm probably doing a horrible job of explaining this. I am not a sheet metal guy, but to those who do perform sheet metal work, those people are like artists. So time to time you will see repairs on certain components of aircraft, such as the sheet metal on the outside or on an engine. And one thing to pay attention to is the edge distance. Edge distance is determined how far that rivet has to be away from the edge of the sheet metal to where it is. That's determined by the diameter of the rivet. Example, a countersunk rivet, which you saw right there, and you're going to see right here, minimum edge distance is 2.5 times the diameter of the rivet. So let's say if the rivet is 5/32 of an inch, the minimum edge distance should be 5/16 of an inch or about 8 millimeters. When using a conventional button head rivet, it's usually 2 times the distance. Just to clarify, the diameter of the shank, not the rivet head. The AC 4313 also goes on to explain the single row rivets, double row rivets, triple row, and etc. There's very specific ways to do this. I am not going to talk your ear off and explain it all. Go ahead and feel free and read it, because it will take me a day and a half just to explain any of this. One chapter.
Well, looks like oxygen is a little bit below limits. Minimum has to be 1350 for the Eops flight, so I'm going to change out the bottle. No big deal. Let's go. Time for maintenance. All right, back in the belly of the 777. There you go. Here's, you guys seen this a million times. Anyway, there's the oxygen bottle. Just gotta close this out, change it out. You guys see me do this a million times. Easy. Look at all this cable. That is nuts. There you go. The overpressure is off. So this is basically in case there was a overheat in this compartment or the bottle is overpressured. Instead of the bottle exploding in here, it would dump the pressure overboard. So this line goes straight overboard. Anyway, all is good. I got the side capped off. All I got to do is just loosen that, pop it out right there. This little ring will slide down. You'll see it in a second. And the bottle comes out. Super easy. And as always, as a precaution, remember, never have dirty tools when working on oxygen. Always have clean tools. Grease and oil don't mix well with oxygen. Bad things will happen, like explosions. A little more. There you go. Got the torque wrench. Now we go back. All right, we got some more witness cable. We got the leak detector. There you go. And that's the new bottle. Yep, as you can see, fairly easy. Just gonna put this all back together and then torque it.
I'm sorry I didn't get a chance to film the whole thing. It was bits and pieces of it. I have an older video that I show the whole process, but I think you get the idea. After everything being put back together, torqued properly, we do a leak check, make sure there's no bubbles. All was good. Brand new bottle, back into serviceable limits. Some of you may ask me, how come you just don't service the bottle on site? Well, we used to do that. Now we have a dedicated oxygen shop at the hangar. We already have bottles that are filled and hydrostatically tested that are ready for us. We simply remove the old bottle, take it back to the shop, and we'll pick up a brand new bottle or a refilled bottle.
Always fun to walk around the equipment bay. It's tighter and tighter and tighter. It doesn't get any bigger in here. Definitely tight quarters. Way to go, huh? These machines are amazing. All right, this is getting way too hot in here and way too tight. Oh, this is really important right here. Check this out.
This is actually a very important tool. This is when you're working on electronics on the aircraft. Aircraft electronics are very sensitive. Any kind of electrostatic sensitive equipment needs to be discharged, or actually you need to be discharged, because you are a walking, talking electromagnetic force. Yes, your body builds up static electricity. And in order to dissipate that static electricity, you need to ground yourself. This prevents damage to the sensitive electronic equipment. It's a bonding strap. That's about it. And every aircraft have these inside their equipment bay.
Success. That's exactly where I want it.
Along with the oxygen bottle that we changed out, also we needed to service a couple of tires and a few minor inbound items, a tray table, things like that, a light bulb. It was fairly simple, but we got it all done. Everything got serviced properly and the airplane got dispatched on time. Well, since we're on a topic of grounding, let's take a look at this. This is a stud, just like me. Now, I'm just joking. It's a grounding stud. You will find these grounding studs on the main landing gear and the nose landing gear. This is how we ground the aircraft. Typically, on a live turn like this, the only time it's being grounded is when the aircraft is being fueled. All of this equipment generates static electricity. The one thing you don't want is static electricity, especially when you're fueling an aircraft. Typical standard is aircraft to apron or to ground, refueling unit to ground, refueling unit to the aircraft, and refueling nozzle to the aircraft. Once all is properly grounded, this will prevent any kind of creation of a spark between the metal parts of the aircraft and prevents an explosion, which we don't want.
Well, that's about it for today, guys. Hope you guys had fun. It was nice. You got to see some cool stuff. I'll see you bright and early in the morning.
On to the next day. Let's go. We're not done yet. Got some good rest, back at it early in the morning. Got my cup of coffee, and I see my beauties rolling in from the hangar. They got maintenance performed overnight. It's always fun to see the super tugs bringing the airplane up, and I always like to catch this little moment right here on how it actually cradles the nose gear and lifts it up. The reason they use super tugs is because it's, first of all, much safer, and second, it's less wear and tear on the aircraft. Conventional means of moving the aircraft around is still being used with tug and tow bar, but that's usually reserved for live flights when the aircraft being pushed out and dispatched.
Good morning. Let's start off with the party mode. Why not? Pretty cool, huh?
Since we have plenty of time until the aircraft had to actually go, I figured, you know what, let's go through the fun little cycles of all the interior lights, or the variety of them. This one's called Carnival. I always enjoy playing around with the lights because it's pretty cool for me anyway. I enjoy watching the transitions and all the effects they have. All those lights are LED. There's a couple of more pre-programmed light configurations I wanted to show off, so enjoy it. Next time you're flying around, just for fun, ask the flight attendant, see if they'll do it for you. But ask them politely, obviously, and see if they'll turn on the fun configurations of light for you.
Yep, here comes the next office. This one's coming in from Philly. It's a quick turn. Going right back out to Philly.
Okay, on to the next topic. I want to talk about tires. If you didn't know, there's a lot of tire manufacturers. This 787 is equipped with Bridgestone tires. You also have Goodyear that makes tires. You have Michelin, Dunlop. All these manufacturers are making aircraft tires. These are radial tubeless tires, and they are rated for certain speeds and skids. Matter of fact, Dunlop does an incredible job. Here's their website. I highly recommend you guys go check this website out. It gives you a plethora of information on everything you want to know about aircraft tires. There's a ton of information not only on the tire itself, but also on the wheel assembly or the rim assembly. everything from part numbers, serial numbers, the ratings, and even modifications. Pay close attention to this tire on the right, and then I'm going to compare it to the one on the left. Are you seeing the difference? Look real close right there. Guess what? Yes, aircraft tires can be recapped. The R dash and that little circle, and if you saw inside that circle, it said 1. That is designating that that tire right there has been recapped once. It's on its second life. Once it's recapped, brand new designations of the speed limits and the skid ratings all get embedded onto that little area right there. Here's another example. This is the nose tires of the 787. Once again, look, this time it says 2. That means that tire has been recapped twice. It's on its third life. Now, there is a limitation to this. You can't just keep recapping the tire over and over again. The maximum amount of time or amount of times you can recap a tire, I believe it's 7 times, depending on the severity of the damage of the tire. If it's not that severe, they'll keep recapping it. But if it's too damaged, they will just scrap the tire. But overall, now you know, aircraft tires can be recapped. Here she is. Beautiful plastic princess. Looking beautiful as ever. This one's perfectly fine. Hook is clean, no inbounds. She's actually ready to go. Quick turn. Oh, before we go, remember last week I showed you guys that the observers have a tray table. So I showed you on a 777. Well, here's what it looks like on a 787. Right there. And right here. One thing I did forget to do on a 777, which also it has. There you go. Pretty cool, huh? This is an Airbus 321, but all 320 families are exactly identical when it comes down to their hydraulic systems. This is the servicing panel. If I needed to service hydraulics, I would simply select the system I want, which there are 3 systems, green, blue, and yellow, attach a hose to the particular filling port, which there are 2 actually. One is a quick disconnect and one is a conventional hose attachment. This one's the quick disconnect right here. It's a pressure filling. There's a very specific coupling that goes onto there, which goes to a Bowser, and you just pump. The other one is right here, the conventional one. Both work very good. And there's also a way to do it with its own handle. The aircraft on the other side has a handle. You would take this thing right here, take it out of its holding device, and there's little splines inside there. Can you see them? You take that handle, you go back around to the other side of the panel, as right here. You insert it in there, and then you pump. You back and forth, back and forth. You know, you can also actually open cargo doors. Let's say if the hydraulic system was down, but there's still fluid in the system, you can pump open that cargo door utilizing that same handle. The purple knob right there you're seeing, that's to depressurize the reservoirs if needed for maintenance. Also observe the hydraulic fluid levels through the eCam right there. There's a specific hydraulic page just dedicated for that. Don't know what happened to the weather. It was supposed to be nice and sunny the whole weekend, but we got doom and gloom for some reason. But it doesn't stop me from having fun and enjoying the airplanes. A little bit of downtime, waiting for the next flight. Get to watch the airplanes take off and taxi by.
And we're back in a 777. This is going to be the final bird. Just getting it ready. This one's actually going to go to Sydney later tonight. Oh yeah, almost done. Something cool I always forget. Check this out. So this is the test light. You go, well, you can set the lights to dim or bright, but watch this. You go test. You get the Christmas trees. Everything lights up like a Christmas tree. But this is the cool part. This is the pitch indicator. And that's for the rudder trim. Well, I should say this is for the stabilizer.
I don't know what's with me. The simplest things make me happy. Seeing a silly little animation of the light indication or the test of the lights makes me happy. I don't know. Go figure. I am a very simple creature. But overall, that's about it, guys. I hope you guys enjoyed this Stig shift. We saw some cool stuff. The cars were pretty awesome. Learned a few things here and there. But yeah, hope you guys enjoyed it. Hope you had fun, learned some new stuff. And I will see you guys on the next adventure. Take care of yourselves. Later.